Hey, hi all. So once again, welcome to Mathematics Mania YouTube channel. So we were continuing with solving the nth derivative using the Leibniz theorem. Yeah. So we'll see the next question. Yeah. So the question is, if y is equal to a cos log x plus b sin log x, then show that x square y2 plus xy1 plus y equal to 0. That's the first part of the question. And the second part of the question is x square yn plus 2 plus 2n plus 1 into x of yn plus 1 plus n square plus yn equal to 0. So we have two parts here in this question. So let's start with whatever is given. So yeah, so y will be equal to a cos log x plus b sin log x. So let's differentiate the y with respect to x. What happens? Y1 will be equal to, a is a constant, I am writing it as it is. Cos of something is minus sign, so that will be minus sign of log x, and we have to take the derivative, we have to apply the chain rule and get the derivative of this log x also. So derivative of log x is 1 over x, so that divided by x will come into the denominator, plus b is a constant here, I will write it as it is. Sin of log x is cos of log x, and the same thing again, chain rule, derivative of log x is 1 over x, so x will come into the denominator. So we see x is there in both of the terms in the denominator, so I will take the x common and I will multiply it to this side. So that will become x into y1 will be is equal to minus a sin log x plus b sin log x. Okay, now we have got the expression in y1. Now again we will differentiate with the above equation with respect to x again. So what happens now, here we have to apply the product rule. So what happens, first function into derivative of the second function y1 will become y2 into derivative of derivative of the second function y2 plus y1 I am keeping as it is here. The derivative of x is 1, so that will become y1 itself, that will be equal to minus a, let it be common outside. So what happens, sin of log x is cos of log x, so that will become minus a cos of log x divided by x, because the chain rule log x is 1 over x, plus b sin log x will become, sorry, this is cos log x, right, sin log x by x, and this is cos log x. Okay, and b cos log x will become minus sin log x, so that is b into minus sin log x divided by x. So again x is there in the denominator in both the terms, so I will take the x common outside and I will multiply here. So that will become x square y2 plus xy1 will be equal to, so what is this, minus a cos log x, minus the minus sign is there, so I will take the minus sign outside, so b sin log x. Okay, so that will be equal to x square y2 plus xy1 will be equal to, minus sign, let me take it completely outside, so it will become cos of log x plus b sin log x. Observe the given function. The given function y is nothing but a cos log x plus b sin log x. So a cos log x plus b sin log x can be written as y. So this implies x square y2 plus xy1 will be equal to minus, this term can be written as y, so which implies x square y2 plus xy1 plus y will be equal to 0. So first part of our answer is covered, that is x square y2 plus xy1 plus y equal to 0. So we have finished showing that the first part. Now we'll start with the second part. In order to show the second part, let's apply Leibnitz rule to the above equation. So what happens, nc0, okay, x2 into yn plus 2 plus derivative of x square is, so here nc1 derivative of x square is 2x into yn plus nc2 derivative of 2x is 2, here it is yn plus 1, right? Yeah, yn plus 1 derivative of 2x is 2 and yn. So we have got the constant term here, so that we can stop taking the derivative of the next terms. So plus xy1 derivative we have to take, that is nc0 x into yn plus 1 plus nc1 derivative of x is 1 and this will become yn, right? Plus the derivative of nth derivative of y is yn, that will be equal to 0, right? So nc0 is nothing but 1, so this is x square yn plus 2 plus nc1 2 into x into yn plus 1 will become 2nx yn plus 1 plus nc2 will be n into n minus 1 into n minus 2 factorial in the numerator and denominator will get cancelled, so we will have 2 factorial here into 2 into yn plus nc0 is nothing but 1, so that is x yn plus 1 plus nc1 is n, so yn plus yn will be equal to 0. So on further simplification, x square yn plus 2, so if you observe here the term xyn plus 1 and xyn plus 1 are common, so I can take xyn plus 1 common from both of these terms, so that will be 2n plus 1 into x of yn plus 1 plus 2 and 2 can be cancelled here, so this will become n square minus n, and here plus n is there and here plus 1 is there, into yn will be equal to 0, so this minus n and plus n can be cancelled. This implies x square yn plus 2 plus 2n plus 1 into x of yn plus 1 plus n square plus 1, whatever remaining is n square plus 1, n square plus 1 will into yn will be equal to 0, which is the required thing to be proved. So that is the nth derivative of the, yeah. So let's move on to the next question. The next question is if cos inverse of y by b will be equal to log of x by m raised to m, then prove that x square yn plus of 2 plus 2n plus 1 into x of yn plus 1 plus n square plus m square into yn will be equal to 0. Yeah, so let's start with whatever is given. So yeah, cos inverse of y by b will be equal to log of x by m raised to m. We have a identity in log, that is log of x raised to n can be written as n log x, right? I mean the power of the this term x can be taken outside. Okay, so the same thing we will do here. So this will become cos inverse of y by b will be equal to m log x over m. Okay, now what I will do, this cos inverse is there, cos inverse of y by b is equal to this one, so the cos of this m will become y by b, so this implies y by b will be equal to cos of m log x over m, right? So now y we can get an equation in y, so y will be equal to b into cos of m log x over m. Yeah, now we will start differentiating the above equation with respect to x. What happens, y we are going to differentiate with respect to x, we will get y1 will be equal to, b is a constant, I am writing it as it is, cos of something will become minus sin of something, so that will be minus sin of m log x over m. Okay, apply the chain rule again here. So we have taken the cos function, so again we have to take the derivative of this m log x over m. So this m is a constant, so m will be getting multiplied here, and the derivative of log x is 1 over x, so derivative of x by m will become 1 divided by x over m. Also we have to take the derivative of this x over m. The coefficient of x is 1 over m here, so the derivative of x will become 1 over m. So if you observe here, 1m is in the numerator, 1m is in the denominator, we can cancel it like this. Okay, so y1 will be equal to, minus sign is there, so I will take minus n outside, minus b into sin of m log m log x over m, okay, into 1 over x by m is there, so that means it will become m by x. So m will go to the numerator and b will come to the denominator, right? So this implies that I will take this x to this side, so this will become xy1 will be equal to, here m is a constant and b is also constant, so I will write it this side, minus mb into sine of m log x over m, okay. So this we have got an equation in y1. Now again differentiating the above equation with respect to x, what happens? Now we will have to apply the chain rule again here. So the first function into derivative of the second function, that is y2 plus y1 into derivative of the first function x, that is 1. So xy2 plus y1 will be equal to minus mb, let me write as it is. So sine of something will become cos of m log x over m, right? Yeah, and now again you have to apply the chain rule. So the derivative of m log x over m will be, m is a constant, so m has to be multiplied. So log of x by m will become 1 divided by x by m into the derivative of x by m is 1 over m. The coefficient of x is 1 over 1 over m here. So 1 m in the numerator, 1 m in the denominator will get cancelled here. So this implies, so yeah, see x by m is there, so m will go to the numerator, x will come into the denominator, that is xy2 plus y1 will be equal to minus m into b into cos of m log x over m into, this will become m by x, right? So this x I will multiply to this side, and this m is there, so already 1 m is there, that will become minus m square. So this implies that x square y2 plus xy1 will be equal to minus m into m will become minus m square into b cos m into log of x over m, right? So if you see that, just observe here, what is y? Y is b into cos of m log x over m. So this is b into cos of m log x over m. So this term can be written as minus m square y. So this implies x square y2 plus xy1, okay. Here minus m square y, so I will take that to this side, so that will become plus m square y will be equal to 0. Yeah, now we have got an expression in second order. Now we will apply the Leibniz rule. Now applying the Leibniz rule, what happens? So this will be nc0 x square into yn plus 2 plus nc1 derivative of x is 2x into yn plus 1 plus nc2 derivative of 2x is 2 into yn. So the first nth derivative using the Leibniz rule for the first time is completed because constant term already came. So plus second term we will apply the same thing, so that will become nc0 first function into yn plus 1 plus nc1 derivative of x is 1, so that is 1 into yn, again we can stop here, plus m square is constant and the derivative of y is yn, so that will become m square yn will be equal to 0. Now let's simplify this. nc0 is 1, so that is x square yn plus 2 plus nc1 is nothing but n itself, so that will be 2nx into y into n plus 1 plus 2 is there here, nc2 is nothing but n into n minus 1 into n minus 2 factorial in the numerator, and the denominator will get cancelled, so that will become n into n minus 1 into 2 divided by, so this will be in the denominator 2 factorial will be there, into yn plus nc0 is nothing but 1, that is x into yn plus 1 plus nc1 is nothing but n itself, that is n yn plus m square yn will be equal to 0. So that is x square yn plus 2 plus, so observe here 2n into xyn plus 1 and this xyn plus 1 are common, I mean similar terms. So xyn plus 1 I will take outside from here, so that will become 2n plus 1 into x of yn plus 1. I can take it outside, I mean write it like this, and this 2 factorial and this 2 can be cancelled. So n square minus n, I will multiply here, so this will become n square minus n in the yn term, and what is remaining is plus n and plus m square is remaining, so plus n plus m square. So everything is with yn, so this will be equal to 0. So this minus n and plus n can be cancelled. This implies that x square yn plus 2 plus 2n plus 1 into x of yn plus 1 plus what is remaining is n square plus m square, that is n square plus m square into yn will be equal to 0, which is the required thing to be proved. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.